Hello everyone, welcome back to my channel. Hope all are doing well. Myself Manasa KV. I am currently pursuing my 6th semester BE Computer Science Engineering at Sri Venkateshwara College of Engineering. Today I am here with a very interesting subject, that is System Software and Compiler Design. Today I am going to explain how to solve a problem and find the object program and object code for SIC-XC machine. So before going to that, we will see the basics part of system software which is required for the solution of SIC-XC machine architecture. First, we will see what is the definition of system software. System software is a type of computer program which is designed for running both the computer hardware and application programs. This system software is very important for each computer. Without system software, it is not referred to as a computer. So, there are different types of system software. It is divided and used based on their essential characters and features. So, there are some common type of system softwares which are used in most of the time. That is operating systems, device drivers, middlewares and utilities, also the program language interpreters. Operating system will help as a bridge between the computer hardware and also the software part, and most of the other also make the way like this to the system software. Then we will come to the application software. Application software is also referred as application program or application software. It is a computer software package. It is a package of softwares which are helped to perform a specific function which are directed by the users. So, these application softwares are externally inserted to the computer, but system software is inbuilt. Then also we use this application software on the requirement of the end users. There are some of the examples for application softwares, which includes Microsoft products, music apps, real-time online communication. Most of the online communication systems are application software like Microsoft Office, PowerPoint, Excel, Microsoft Word, Microsoft Outlook and many more. And also the music apps which are very using in the present criteria are Spotify, Pandro and the real-time communications which we use to communicate virtually like Skype, Google Meet and Zoom. It is a schematic diagram which shows the connection between hardware, system software and application software. These three are interconnected. The hardware refers to the computer hardware system which is internally connected. System software is a very basic need which will connect the application software and the hardware together. System software acts as a bridge between hardware and also the application software. And the application software which is installed into the computers as it is used by the users. So application software is externally installed to the computer to make the computer to run as the end user required. Then we come to the simplified instructional computer. What is simplified instructional computer? It is also short formally called as SIC. This SIC is a hypothetical computer. It has hardware features more oftenly which are found in the real machines. So it includes the features of the hardware, not the software. It is the architecture. There are two types of simplified instructional computer like standard model. Another one is extension version, that is extension version of standard model. So we will look into both of these separately. First, we will see SIC machine architecture, which is a standard version. It consists of memory, register, data format, instruction format, instruction set, and input-output device. So, memory. Memory consists of 8-bit bytes. It has 3 consecutive bytes to form a word. A word can be formed with 3 consecutive bytes, that is total of 24 bits. One word is of 24 bits in length. Memory consists of total 2 power 15 bytes in the computer memory. Register. For standard machine architecture, for a register there are 5 registers. Each register of 24 bit in length. Example, A is of 24 bit, X is of 24 bit, L is of 24 bit, and other two also each have 24 bits in length. So, the 5 registers which are mentioned here are the most important registers which are used by the standard version of machine architecture. A referred to as an accumulator. It performs the functions of accumulator. X refers to index register. L refers to linkage register. PC is a program counter which acts as a program which is waiting in the waiting area until the completion of the other program. It will have the address of the next instruction which is to be executed until it will wait before the completion of the others. Then SW, it is standard word or status word. Then data format. Data format will store the integers. It will not be supportive for the floating points or floating values. So this data format will store the integers of 24 bits in the binary number. Binary number means zeros and ones. 2's complement represent the negative value. The 2's complement will always be the negative value. It will not be in a positive value. Characters are stored using the 8-bit ASCII code. Characters always be stored as a ASCII value with the 8 bits. And as if I said, no floating point hardwares on the standard version of SIC are used. Instruction format. Instruction format is a format where we will be storing the binary numbers and dividing it. Here we have the 3 sections. First section is a opcode, second one register, third one address. Each have their own bit length. Opcode is of 8 bit, integer is of 1 bit, and address is of 15. X is a index register, what we have seen in the register part. Opcode will be of 8 bit and address will be of 15 bit. Next one, instruction set. We have 5 types of instruction set here. First one, load and store register. These are the load and store register will load the register and store the register. LDA, LDX, STA, STX. LDA and LDX perform the load registering operation. STA and STX refers to the store register operation. Second one, integer arithmetic operation. Integer arithmetic operations are like same as the arithmetic operations which are performed like addition, subtraction, multiplication and also the division. There are the conditional jump instructions which are used in these special cases like JLT, JEX, JGT. And also we have the subroutine linkages like JSUB and RSUB, which are used in the instruction format of standard SIC. Then we have the input and output devices. Input and output are performed by transferring one bit at a time to or from the rightmost 8 bit of the register A. Here the input and output operation will transfer the byte for the rightmost or the leftmost by carrying the 8 bit from to or from the rightmost bit of the register. We have three types in the input output devices like test divide instruction, read instruction and write instruction. Read device instruction will test the bits which are to and from the rightmost bit of the register. Read data will read the data which are to or from the rightmost bit, and write data will perform the write action which is moved from to or from the rightmost bit of the A register. These are the some of the concepts which are used to design and solve the problems of SIC machine architecture. These are the basic which are required for the solution of the standard SIC machine architecture problem. Then we move on to the another one, that is SIC-XC machine architecture. It is the extension standard version of SIC. The same concept is repeated here with the some more features like memory, register, data format, instruction format, instruction set and input devices, which are all common, but in that they have some special features than the standard SIC version. So here the maximum memory available is of 1 megabit, whereas the total memory of the SIC machine is 2 power 15 bytes. Here we have the 1 megabyte of memory storage available, which is of maximum. Then register. Along with the SIC machine, here some more 4 registers are added. Like in the SIC we have A, L, P, C, X, SW. So here we have B, S, T, F are the register. Here B refers to base register, S refers to general working register which are used in the program, and T also refers to the general working register. F refers to the floating point accumulator. In SIC we use A for the accumulator. Here F refers to floating point accumulator. Instruction format. In SIC we have only a single type of instruction format where we have seen opcode, register and address, where 8 opcode, 1 bit is of register and 15 bit of address. Here we have 3 types of formatting which are very much used. So the 4 types of formatting are format 1, format 2, format 3 and format 4. Format 1 is of 1 bit which consists of only the opcode. Then format 2 has opcode with the 2 registers which are represented as R1 and R2. Format 3 is of 3 bytes which has the flag bits in it. Opcode is of 6 bit and the flag bits we are using as direct addressing, indirect addressing, index register, base register, program counter and E, and also the address is of 12 bit. Here the flag registers which will have the 1 bit area in the memory. If the E value is equals to 0, then it is of format 3. If the E value is equals to 1, then it is of format 4. Format 4 will also be similar to the Format 3, which has the opcode and 6 flag bits with the address area of 20 bits. These 4 formats are used in the SIC machine architecture. Then the addressing modes. As we discussed here, the number of flag bits is of 6. Each flag bit have their own address modes, so which are discussed here. Base register. If the base register is present, then N, I and B is equals to 1, where the program counter value will become 0. These values must be known to the user while solving the problems on SIC XE machine. This slide is very important. We have to memorize this to solve the SIC XE machine architecture. Then direct addressing, where for the direct addressing N value will be 1, I value will be 1 and B and P will going to be 0. Immediate register N value is equals to 0, I value is equals to 1, X value will be 0. For the index indirecting N is equals to 1, I is equals to 0 and X is equals to 0. Extended, as I say, if the format is 3, then extended value will be 0, or else if the format is 4, then the extending value will be 1. Then instruction set. Here also we have load, store, register, floating point, arithmetic operations like add F, subtract F, multiplication F, divide F. Here F refers to floating point, adding the floating point, subtracting the floating points, multiply and dividing the floating points. Here we have a register to register arithmetic operation, which are adding the register, subtracting the register, multiplying the register and dividing the register. And we have a supervising call instructions as SVC. These are the instruction set which are used in the SIC XE machine architecture. And the last one is input and output device. These are the channel which is used to perform the input and output operation while the CPU is executing the other instruction. Whenever the CPU is executing the another instruction, the input and output operation will use this IO channel. Then we will see the problem on SIC XE machine to generate the object code and also the object program for the present given question. Here I am going to give a brief description about this problem. Here the sum of the values like clear, JDT, TD, JEQ, LDCH, WD, TIXR, JLT, RSub and also the address and buffer value is also given with the length address also given. So this is a simple program where I am going to explain how to generate the object code and also the object program. Here we have the program with the location center, starting address and also to generate the object code. First, the location center will be written as if I say we have to know which type of format is this are referred to. So first one, they have given the starting address as 405D. So we have to write that same address at the starting position of location center, that is 405D. Then we will write the next address as by looking into the address format where we have used the register. X is a register. So this refers to format 1. Format 1 has a only 1 bit length, and here we have clear X. X is a register. Registers are used in the format 2. So it is of format 2. So add 2 to the 405D, then we will get 405F. Then LDT length is of format 3. So add 3 to the next successive location center. So like adding the format number bytes to the location center. Here LDCH buffer X, it is of format 3. The format 4 are represented with a plus in front of them. Like in the start section, if you have any plus, then it will refers to the format 4. Then after completing this location center, we will be focusing to generate the object code. Here is a step to generate the object program. Here, after completing the location center, we have the location of the each instruction which we have already calculated. Then for the first one, it is referred to a format 2, where format 2 is of 2 bytes. So we have the format like opcode, register 1 and register 2. We have the mnemonics and number table where the register and the register value is placed. So opcode, for the clear, we have the value in the topmost of there. They have already given the value as B4. The B4 is written in a binary number code like 10110100. This B4 is written at the opcode space where it is of 8 bits. So all these bits are going to fix in this opcode section. Then we have the two register R1 and R2. X is 2 of, here the register X is of 1. So 1 will be of 0001 in binary value. So 0001 is stored at the R1 position. R2 will be of empty. So we have to fill it with the zeros binary value, so that we will get the answer as B410. Then we will move to the next instruction, that is LDT length. It is of format 3. How we come to know this? Because length, output, wlook, these are all LDT, TD, JQ, which are referred to the format 3. If we have the plus in front of this instruction, then we will say it as a format 4. Both the formats will have the same instruction formatting, but it will be differ with the flag bits. So for this length, we will be writing the instruction format. Here we have the instruction format as opcode, NIXBPE as a flag bits, and 12 as a address. So here LDT will have the value which is given already in the program as 74. 74 is written in a binary number value, so that is placed in the opcode section. 01110100. Opcode is of 6 bit, so last two numbers are neglected and only the first 6 numbers are placed at the opcode section. Then the flag bits are to be marked. Here the index register value will be 0 and also base register value is 0. The program counter and NI is of 1 bit because it is a base register. Base register will have the value N is equals to 1, I is equals to 1 and P is equals to 1. Here this instruction we already say that it's of format 3. So the extension value will be 0. So the address should be in the 12-bit range. So here we are calculating the address like 4036 minus 4062 minus, it will be making the value as minus 2c. Minus 2c, if we return in the binary value as a hexadecimal, we will be getting FD4. So the program relative this value minus 2c will be between minus 2048 to 2047. In this range, the -2C will be lying, so it is considerable and will be written in the address section. So we will get the value as 772FD4. Here we get 7724D4. Then we have the next instruction. These are the instructions of format 3. So the same procedure will be carried out till the end of the program, where we will be reaching the end. Here we can see I already solved it in the format. So we have the solutions for the third one. WL loop will be E32011, and for the JEQ W loop 332FFA. For the buffer and X we have 53AF68. For WD output DF2008. Tixer T8850. JLT W loop 382FEF. R sub 4F0000. R sub will not have any address which will be searched in the next column, so we use it as a 4F, and the other bits are filled with 0. Byte in with the index register of 05. The same register will be written at the object program because it is not be altered. So these are all already given data. Using the given data, we only solved the object code and generated the object code for this program. Next we will see how to generate an object program for the same problem. Object program consists of head, text and the end. Head of the column 1 will be of H, column 2 to 7 will have the program name, and column 8 to 13 have the starting address which is in hexadecimal, and 14 to 19 will have the length of the object bytes in the hexadecimal. Then text is also same. The first column represent T, 2 to 7 column represent the starting address, 8 to 9 represent the length of the object code, and 10 to 69 refers the object code representation in hexadecimal. Then end. The first column 1 will be of E, and 2 to 7 represent the address of the first executing instruction of the object program which is in hexadecimal. Now we will generate the object program for the program which we have find the object code. Here this is the object program which we have generated. This is the object code which we have found in the last sum. The same sum is taken and solved the object program for it. The first line is of head. The first column is represented with a H and a space with the starting of the name of the program which is here WRREC after the location center in the first row. So which is written here. Then the starting address of the program, that is 405D. Then the ending address of this program which will be calculated by subtracting the last address with the first address, so that we will get as 001A. Then the text part. The text consists of the first column is of T. Then 2 to 7 as the address of the first instruction, that is 405D. Then we have to write the successive object codes till it reaches to the 69 bits. The total length of the text should be of 69 bits. The first T and the address and also the space consist of 9 bits. Other 60 bits should be written by the object code usage. Then after returning the object codes, we have reached the end. So the first column represents the E, that is end of the object program. Then we have say that we should write the first instruction which is execution, that is the starting address is the first instruction address where the execution of the program starts. So that is 00450D. it should be of 6 bit in length. So we add double zeros at the front of the program. This is how we will generate the object code and the object program for the SIC machine architecture, which is very useful to learn and enjoy the programming subject. So using this, we have calculated the 3 steps, where in the first step we calculated the location center by finding which format the address is given. If the format is 2, we have 2. If the format is 3, we add 3 to it. If the format is 4, we add 4 to the address and get the next location center. Then we created the object code by using the formats and the flag bits. Then we learned the object program, how to write the object program, head, text and end of the program. So that's all for today. Thank you for watching. Thank you for learning.